Okay, I want to start with a clean slate, so I'll delete the server and the client deployments on the cluster, kubectl delete deployment greeter server, and followed by kubectl delete deployment greeter client. And we don't have any pods, we don't have any deployments, it's all clean. So let's start with the server as usual. We'll edit server/main go. Our first to-do item from long time ago is to establish a secure connection using the SPIRE workload API. For that, we'll use secure credentials this time. So I'll just delete this part because I don't want insecurity, I want security. And we'll initialize secure credentials using the workload API. In SPIRE lingo, the stuff that you get from the workload API is called source. Source can contain both the current workload's SWIT X509 certificates and also other trust bundles that can be used to verify other identities that this workload is talking to. So we get the source by asking the workload API to give us a new X509 source. And I'll do some basic error handling here as well. And as a good boy who cleans up his mess, I'll defer closing this source too. And that's all about how we get the source. Now it's time to
use the source.
And while we are at here, I'll add some dependencies that I know we'll need. But first, I'll remove this insecure gRPC credential, which we don't need it anymore, because from this point on, all of our workload communication will be secure. And I'll add a bunch of Ghost SPIFFE libraries that will help us talk to the workload API and parse bundles. Since I have the source, now, for example, I can get and print the SWIT of this current existing workload. We can also use the source we just acquired and create secure gRPC credentials like this. Here, the first source argument is the source of the workload's SWIT, and the second source is the source of the trust bundle. In our case, both of them are the same. They might not be in different cases, but the API gives the flexibility to use it however we like. Also, by authorize any, we are essentially allowing any connection as long as the workload identities are valid and trusted by SPIRE. So in a sense, we are authenticating but not authorizing actually. And if we want, we can add more controls over this. We can leverage a policy engine like Open Policy Agent, for example, to allow a more granular, more policy-based authorization. And all of that authorization logic can be done in this authorizer parameter that we pass here as an argument. We'll see a slightly more involved kind of an authorizer when we begin implementing the client part of this mTLS authentication in an upcoming video. But overall, that's all you need to establish the server end of the mTLS connectivity. And again, instead of doing this inside the code, there are other options. For example, you can lay out a service mesh, such as Istio, and then let SPIRE modify Istio's Envoy proxy using the Envoy Secret Discovery Service, or STS API. And in that case, you don't even need to change any code at all. Everything will be handled by Envoy behind the scenes. You can even go one level further and use SPIRE as a certificate authority for Istio, and that will allow you to configure the Istio service mesh network policies based on SPIRE SWITs using OPA Rego files and policies. You name it, you can go as declarative, as granular as you want. But to be honest, changing the code and adding a couple of lines is not too big of a deal as well. So it all boils down to where you want to isolate your complexity, if you will. There is no one true solution that fits all. There is no one true best practice. And as always, it depends. It depends on your use case. It depends on your problem. It depends on what you're trying to achieve, honestly. But enough ranting, back to our code. If you remember, there's another to-do item in this server code. Since we have the client's SWIT now, we can get the client's identity. For that, we will get the client's ID from the context here. And if we have it, we'll print it. And if not, the client will default to unknown client again. And that wraps up the server. Let's save it and quit the editor. Then I'll build another container image for the greeter server application by running heck build sh again. Then we'll do some changes in our deployment manifest. So this is our SPIRE agent socket volume that refers to run SPIRE sockets folder on the node that this workload is running on. and we mount it as a volume to our container. Finally, we define an environment variable for the SPIRE agent socket so that the workload API will know where to look for the socket and then fetch SWITs and trust bundles for us. And that's all the changes we need on our deployment manifests. Let's deploy our server. kubectl apply -greeter server YAML. And when we check the logs, we see that our server can receive and parse its SPIFFE ID, which is perfect. It means that we have installed SPIRE successfully onto our cluster. Our SPIRE server, SPIRE agent, and the workload API are working. The pod has attached to the Linux domain socket. It can use the workload API to fetch SWITs from the Linux domain socket and then parse that SWIT and get a SPIFFE ID that identifies itself. And all of these happened transparently behind the scenes. And I think it's a good point to stop here. In the next video, we'll update the client side of things. So see you there.